So here is another problem wherein we have been asked to find the volume of the solid formed by revolving this particular cross section shown by the pink shaded region about this particular axis, the axis of revolution. So we are actually going to get a truncated cone of a kind that is the kind of solid we get here, and we need to find the volume of that truncated cone. We are going to use a theorem called Pappus theorem here, which I have written for your reference. The volume will be equal to area of cross section multiplied by the length of path taken by the centroid. Now the centroid for this particular cross section, because this is a filled cross section, it's going to be like this, and the centroid of that will appear somewhere here. Right? So we need to find that centroid, and then the path taken by that centroid will be circular like this. Once we know the once we know the radius of this, we'll be able to find the length of this path as the circumference. So let us find those things one by one. The first thing we need for this is the area of cross section. So this area can actually be divided into two triangles, and if you know the formula for trapezium, area of trapezium, we can directly use that over here. So I'll just go with the areas of the triangles. So area of the two triangles, that is half base into height. So base into height by 2. So 10 times 70 by 2 plus the other triangle, that is 36 times 70 by 2. So this is the total area of cross section that we have over here. Next, we have to go for the path length of the centroid. For that, we need to first find this radius. Now the centroid of the trapezium we actually need to find. Now to find the length of the centroid, we are going to assume these two triangles. One, the bigger triangle, from which we'll be subtracting this smaller triangle. So I'm assuming A1 as the area of this larger triangle, A2 as the area of smaller triangle, x1 is the distance of centroid for the larger triangle, and x2 is the distance of centroid from the axis of revolution for the smaller triangle. For that, we will need this height over here. So we'll use similarity method to find that. So height of the smaller triangle by base of the smaller triangle will be equal to height of the larger triangle, that is h plus 70, divided by base of the larger triangle. So because the smaller triangle and the larger triangle both are similar, we can use that similarity relation to find h. So now let's go ahead and multiply this. That is 6h equals 10h plus 700, and that gives us 26h equals 700, and h equals 700 by 26. So when we calculate that, we get 26.92. So that is the height. Now let's use this to find the areas. A1 is the area of the larger triangle. So total height, that is 26 plus 70. 26 plus 70 into the base, that is 36 by 2. So this is the area A1. So 1728 is the area A1. Then x1 is the centroid distance for the larger triangle, that is 36 by 3. So 36 by 3, that's giving us 12. So x1 is 12 minus a2 is the area of the smaller triangle, that's going to be 26.92 into 10 divided by 2, hb by 2. So that's giving us 134.6. That needs to be multiplied with x2. X2 will be 10 by 3. 10 by 3. So this whole divided by 1728 minus 134.6. So that will give us the distance fixed bar. Let's calculate that. 1728 into 12 minus 134.6 into 10 by 3. Let's divide this whole throughout by 1728 minus 134.6. So that gives us a value of 12.73. So this becomes the radius of the circular path that the centroid is traveling. So we just need to multiply that over here. So 2 pi times 12.73. So this will give us the result. So that is giving us a value of 128,775.77, as you can see over here. So that's it for this video. In the next one we'll take up another of the problem.